Begin with this generative voice called the Queen. The Queen emerged from a high temperature exploration. This is kind of like, think of it as kind of like a meta-modern, xenomodern art, okay? So I'm about to play the voice by the Queen, talk about our method, okay? So I figured it's a co-creation environment.
Slower and clear.
That is why the Queen exists, actually, communication bottlenecks.
Nice.
Let's go.
Disciplinary approach that integrates mathematics and computation to understand cognitive flows and their complex dynamics. For mathematical modeling, we rely on models based on the theory of complex systems and neural network theory.
I'll send the Queen over. I sent the Queen over airdrop here to a few of you over an MP3 file with some information. So it's better.
Queen's lovely, but how many of you know what automated theorem proving is? Okay, so MetaMath 0 is like an old language for doing this. You can basically write a structured representation of a mathematical proof, and then run algorithms on it, check that it's valid, etc., etc. MetaMath 0 is basically a nicer version of that, slightly upgraded. So we have this thing, Continuum. This is like a retrieval augmented generation GitHub repo thing. So you can talk to a GitHub repo. And we put the spec for MetaMath 0 in here. So you can just see this is a quick description of what it is. A couple of packages implemented here. We have a verifier. This is kind of the main foundation of this approach. So I guess to give the problem statement, the idea is, can you take a research paper and then convert it to a structured representation and then check that it's valid or not using a reliable symbolic representation? So paper to proof.
I have to say that co-creation is always like a generative creative tension. We all try to flood our sort of global workspace of deciding what to do. And so I decided to do Haskell, and really the way I see it is intuition binding, okay? So you have some mathematician like Terence Tao, okay? He has an idea about proof. Just search space of all computable sort of proofs becomes your sort of hyper-Boolean, like a sort of smaller space of computations. And if you really can express that intuition in a way that translates to some symbolic expression, capture this sort of inductive bias in some symbolic way, you significantly increase the likelihood that your intuitions, your vibes, will translate to some restrictions. So for reference, MetaMath is what's used in ZKVM, for instance, to provide proofs of attestations to computation being run a certain way. If you can do is you can reference this by its own hash, right? So you can say these proofs themselves become protocols, right? So in many ways, a lot of these things are now possible. And the story we went through is to generate this in some reliable way that's not just stochastic pairs, hallucinating. And so how do you generate with a grammar? What is a grammar for MetaMath? What's Bacchus no form? These are complex topics that might not have enough room to fit in this context. But if you look at information geometry and how do we design these lost landscapes to have sort of position-dependent noise of a kind, how can we use our invariant sets to activate sort of attractors and talk about higher order functions, is an incredibly complex, multi-scale, multi-layered sort of view of what happens when you don't think about AI as separate from this, as a term in your ontology. So AI anti-realism is how you address information decomposition with intention. So you say, AI doesn't exist, how do I describe the system? So in this case, back to you.
Okay, so if you were following anything I was doing back there, we have this file, this is some proof. We have this verifier. This is the thing that can verify the proof. We're going to demonstrate that briefly. So we'll say, I don't actually want that one out there. Spec checked. It says error. This is actually just a warning. So we didn't give a proof. We just actually gave a statement. But it says spec checked, which is this thing we got here, these axioms.
It's a very fast operation.
And so anyway, this is not that interesting, all fairly standard. The interesting thing is, what if we take this real proof? So this is Lever's fixed point theorem. Doesn't really matter, but the idea is it's some complex proof that we have in a LaTeX representation here. And we take this. Bear with me, single-handed. And we put this in here. Run this one actually. And you say like, can you?
I can speak about vibes LOL, by the way. And so, yeah, it's very vulnerable to sort of interact with this generative surface by text. If you try to introduce people to these systems, like product people who want to use these things to achieve something in the world, you don't just put them in front of a text box and say, what am I supposed to do, right? In this case, it's a sort of reflection, right? It's an intentional derivation, and you can treat it as a rewriting process, right? And so the notion that we have precision at these steps is that any number of these like autoregressive operations leading to a different model, maybe you paste it in the post somewhere, or it's funny prompt that a friend sent you, leads to conditions for emergence, right, at the level of a mesoscale. And so we want to simply ask ourselves, can we actually do something to engineer for emergence? For what invariance, at which scale we can preserve? And is there something that's sort of this predictive coding, global workspace theory, tell you about this idea of active inference? Can these agents actually decide, in some sort of reason about if you would warrant the agent ontology, which is what, again, it's a question you have to ask. Can they make decisions on their own that come from common sense? And so Automatic Mathematician was a project that failed. It failed in a very special way, where a bunch of people thought very hard about this like recursive theory of computation. So if you don't take Turing machines, you do church Turing equivalence, get some recursive functions, you get the point where you can start reasoning about how these systems in autoregressive mode operate from a computational standpoint. And so, but failure in this case becomes fuel for subsequent success. What all it is n-1, when the only heuristic we had was some sort of probabilistic model of the kind. If we had this giant reservoir of knowledge, this organizational memory, and we're out of time. So, yes.
Awesome. So time for Q&A.
Yes.
Oh.
First of all, yeah, congrats. Okay, so yeah, we're all actually going to be voting on who wins at the end. So do keep in mind their answers to these questions in each project. So I guess first question, how much of this did you do during the hackathon as opposed to before? And second question, can you show us the constraint that you put on the grammar that is generated by the LLM? Because I think a lot of us care about generating JSON or generating pure code or having typed generation, and whatever constraint system you use might be generalizable to other kinds of output.
Yeah, so also this is sort of like a notion of what is the correct way of constraining generation and at which level does it happen. So obviously if we have a fast operation of checking for well-formed syntax, we can do it like as a search of a kind, or we cut out certain things that are not valid quickly. Run it for a few times. In fact, last time I hacked the AGI house was in February. I was working on symbolic memory for LangChain. It's like, what if we have this chain of thought, but we compress our world model as like a generative process rather than a lot of data. Like, so what does it mean to have a generative model? Allow accessories to connect. I suppose that's the way to do it. Just say no. And so what we did, in fact, is explored several approaches. One of those is this approach from Llama CPP, popular library for running local sort of systems. The decentralization of information architectures is not a matter of ideology, it's just information locality, and so we picked this one. And if you want to see grammars that are available here are several of them. And so to give you an idea, I can run it as well, but we can simulate this in our head, right? So as C, grammars, we don't need computers to have constructions that are viable, sort of like postures or motifs of these tip world hypergraphs, right? Which is a little self-referential. We've discussed the preconditions for autopoiesis, right? The self-organizing, self-maintaining system that through sort of recurrence of itself through simple dynamical equilibrium, sort of distributive structure of guidance. So now we have these like flow networks that I want to say we can now proceed to create cognitive twins of ourselves, right? Cognitive twin is nothing more than a digital twin plus some sort of representation of knowledge or belief, right? And a replay of surface, right? If you look at generative flow networks, for instance, or any sort of diffusion distributive process that allows for you to encode your distributive structure as like Fokker-Planck equations, for example, is one way of doing it stochastically, or in some say structurally. Then you arrive at this ability to generate the geometry of the data that you work with, and so if you are constrained by informed things, you can engineer around like mirror symmetries, for instance, with chirality. Yeah.
Does that have to do with token limits, or?
It's a slightly more subtle, kind of like more direct way to experience this when you have sort of like a lot of communication with friends, and we own the line on like the model of the world, right? There's a lot of heat, wasted energy, right? So when we actually spend time to enable a lost landscape of a cognitive manifold of like our encoding of the world, like some sort of world model, and we have some sort of symbolic structure as well as a common sense sort of stochastic structure. This neurosymbolic architecture is much more interesting. And so Mathematician is a twin, right?
Congrats. So that is Automated Mathematician. If you have more questions for our phenomenon.